Hello to everyone. I am Professor Raja, working as Assistant Professor EC Department, SNS College of Technology, an autonomous institution, Coimbatore. In this YouTube video, I am going to discuss the 8255 programmable peripheral interface. Based on my previous video, you may have something about a knowledge of how a 8251 USART is constructed and the uses. Now I am going to discuss the next IC pin, that is 8255 programmable peripheral interface. So it is also a dual in package IC. It is made up by Intel Corporation. The 8255 is a chip, is also called as a programmable peripheral interface. The Intel's 8255 is designed for use with Intel's 8-bit, 16-bit and higher capability microprocessors. The 8255 is a 40-pin integrated IC designed to perform a variety of interface functions in a computer environment. It is also flexible and economical in nature. This is the pin diagram of 8255. In general, 8255 is a 40-pin dual in package IC. So the signals which used in 8085 are, the first is D0 to D7, which is the data bus buffer, and the right hand side you have a 4 control pins are available, that is PA0 to PA7, PC4 to PC7, PC0 to PC3, PB0 to PB7. VCC is the power supply, ground is the grounding control, address bus, that is A0, A1, chip select, this is CS, reset, and RD bar, WR bar. So we will see individually how this 8255 is constructed. So in general, 8255 is a programmable peripheral interface. It has 24 input-output lines which may be individually programmed. Two groups of input-output pins are named as Group A, that is Port A fully and Port C upper bit. Then Group B, Port B fully and Port C lower bit. 3 ports are available in 8-bit controlled. One is Port A, that lines are identified by the symbols PA0 to PA7. That is, if you see this figure, right hand side, PA0 to PA7, these are called the Port A address lines. Next, Port B lines are identified by a symbols PB0 to PB7. Port C lines are identified by PC0 to PC7, PC3 to PC0. In Port C, the uppers are indicated by PC7 to PC4 and the lower bytes are indicated by PC3 to PC0. So in general, if you see the left hand side, first I am going to discuss the left hand side, then I will move to the right hand side. So now I started with the left hand side, that is the first is the D0 to D7. It is the data bus buffer, the data input output lines for the device. All information read from and write to the 8255 occurs via these 8 data lines. CS, that is chip select, whenever this line is logical 0, the microprocessor can read and write to the 8255. Reset, whenever this 8255 is placed into its reset state, if this input line is a logical, that is a microprocessor and 8255 is ready to do the next operation. RD bar, this is the input line driven by the microprocessor and it should be low to indicate read operation to 8255. WR bar, this is the input line driven by the microprocessor. A low on this line indicates write operation. A1 to A0, these are the address input lines and are driven by the microprocessor. So there are various control logics are used for 8255. That control logics are decided by the CS, that is chip selected signal. CS is called the master chip select. A0, A1 will specify one of the 2 input output ports. In general, if CS bar is 0, A1 is 0, A is 0, then we can select the port A. When chip select is low, A1 is 0, A0 is 1 means it choose the port B. When chip select is 0, A1 is 1, A0 is 1 means port C is selected. If chip select is 0, A1 also 1, A0 also 1, then they will go for the control register. If chip select is 1, and A1 is not selected, A0 is not selected, means the 8255 is not selected, that is 8255 is not connected with the microprocessor. So whenever chip select is 0, then only the microprocessor will have the access to take an output from 8255. Otherwise, if chip select is 1, then we cannot have any access through an 8255. So these are the important block diagram of 8255. If you see this figure, there are 4 important blocks are available. One is the data bus buffer, second one is the read-write control logic, third one is the group A controller, then the fourth one is the group B controller. So in this block diagram, there are 4 important blocks are going to explainable. One is the data bus buffer, read-write control logic, group A, group B controls, port A, port B, port C. So next YouTube. So in this YouTube video, I discussed what is the use of 8255 and what are the important functionalities of 8255. The block diagram of 8255 we have seen, and the important blocks I discussed. Now on the next YouTube video, I am going to detailedly discuss the important functions of all these blocks. So thank you for watching my video.